Okay. Now we will discuss another composite transformation example. Suppose we want to reflect any object with respect to some arbitrary line. Okay. Now, because it is very trivial case that the mirror will be aligned along principal axes, x axis or y axis. That is a very trivial case. Like the rotations will be always confined, the rotation with respect to origin. Okay. Similarly, the scaling with respect to origin, that is not the always case. In generalized case, that we can perform rotation with respect to any arbitrary point, we can perform scaling with respect to any arbitrary point, that is equivalent to the point which remains fixed after scaling. In the same way, we can align the mirror along any arbitrary axes. Consider that mirror is aligned along any arbitrary line L. So, this is the line L. So, this is your mirror, and let the equations of this line is specified by y is equal to mx plus say b. This is the equation of the line. So, any point P whose coordinate is x y, after reflection, that point will be at P dash, reflected point will be at P dash, let the coordinate is x dash y dash. And in the similar way, we require to find out the matrix operator M with respect to the line L, and if this is operated on P, then we will get P dash. So, our target is to obtain what is ML. Here the specifications of the mirror is along any arbitrary line whose slope is given by m. So, if this angle is theta, then it is specified as tan theta is equal to m, and definitely this line is passing through 0 b, okay, and this is your origin 0 b. So, this is the specification. So, in this case, so far we know the mirror reflection with respect to x axis, and we know the rotations and other translation operation, basic translation operator. So, keeping those things in mind, using those fundamental operators, how we can perform a generalized reflection with respect to this line. So, our target is to give basic transformations, so that this mirror will be aligned either along x axis or along y axis, okay. And then we can perform that fundamental reflection operator, and then we will restore the original situations by giving proper inverse transformation operations. How this can be done? Let us see. So, in this case, step 1, to align this mirror with respect to x axis, we want to give transformation so that this mirror will align along x axis. This is x axis and y axis. So, what will be step 1? First, we have to give translation, so that this point, let this point is A. A is translated to origin. So, first one is translate A, that is 0 b, to origin 0 0, and let us call this operator as t minus v, because we are considering v as this OA is v. So, we are considering here OA, this is v, that is nothing but this is bj, because x component is 0, bj. Now, after these operations, this mirror is something like this, something like this. Then we have to give rotation through an angle theta, but in this case the direction of theta is opposite, is along, okay. In this case, that is negative theta. So, step 2 is rotate, okay, with respect to origin through an angle okay, minus theta. Now we call this operator as r0 minus theta. So after this rotation, this is aligned along x direction. Then we apply the reflection operator, which we have already obtained earlier, that is, take reflection with respect to, okay, x axis, that is, this operator is already known to us, that is mx. Then we have to restore the previous, okay, situations, like we have to give inverse of step 2 first, then step 4 we will give back rotations so that the step becomes inverse of step 2. So perform rotation, okay, with respect to origin through an angle theta. So this is r0 theta. This is nothing but inverse of, this is nothing but inverse of step 2. This is inverse of step 2. So after that, every points will be again rotated, and the transformations will be same as this step. Now step 5, which is the inverse of step 1, that is, translate origin, translate from origin 0 0 back to, okay, 0 b, that is, this is nothing but inverse of step 1. So this operations is denoted by TV, because this is along V, translation along V. So if you perform these operations in sequence, then we will get the mirror reflection operator ML. So how this can be obtained? Let us see. So on any point P, which is operated first, step 1, that is, first you have applied T minus V, the operator specified in step 1. With that result, we are applying the operators on step 2, that is r0 minus theta. Then we have applied the operator specified in step 3, that is mirror reflection with respect to x axis. Then we have applied the operator specified in step 4, that is rotation with respect to origin through an angle theta. So this is nothing but inverse of r0 minus theta, and then we have applied the back translation, that is TV. This is inverse of this matrix, and this is your P dash. So if you multiply these 5 matrices 1, 2, 3, 4, 5, then multiplication of these 5 matrices is nothing but your mirror reflection operator with respect to the arbitrary line L, and that is operated on P. So that is P dash. So after this multiplications, everything is known here, because these rotations operators require cos theta and sin theta, which can be obtained from tan theta, because as it is given tan theta is equal to m. So definitely sin theta is equal to m by root over m square plus 1, and cos theta is 1 by root over m square plus 1. So putting this sin theta and cos theta in these matrices, okay, we can easily find the result matrix. So if you put the values to obtain ML, so this is T minus V, first is TV in the left hand side, right hand side minus V. So what is TV, because V is specified here, okay, what is V? Bj. So this is, what is TV then? 1 0 0 0 1 1 0 0 1. because in this case T x is 1 only. Now, what is r 0 theta? This is sin theta. Okay. R 0 theta is cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1, and then mx we have already obtained earlier, that is 1, okay, 0, okay, 1, 0, 0, okay, 0 minus 1, 0, 0, 0, 1, and then what is r theta? We have obtained the composite operators ML, which is the multiplication of these 5 matrices, and putting the value as we have obtained earlier. So, TV is 0, 1, 0, TV is 1, 0, 0, 0, 1 B, 0, 0, 1, and r 0 theta is specified by this matrix cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1, and this is your mx, and r 0 minus theta, here theta is replaced by minus theta. So, cos of minus theta is cos theta, sin of minus theta is minus sin theta. So, that is minus minus cancel out sin theta, and this is minus sin theta, this is cos theta 0. So, this is your r 0 minus theta, and this is t minus v. So, minus v means this is just minus. So, if you multiply all these things and putting the value of sin theta as m by root over 1 plus m square, cos theta is equal to 1 by root over 1 plus m square, putting those value, finally, we obtained ML specified by this matrix. It is just simply as specified earlier, you multiply either, okay, these two matrices with this from the left hand side or from the right hand side. In this way, we get this result. So, this is your composite transformations matrix. Thank you.